Section 2.3, Conditional Statements. Before we begin, take out your notebooks, fill this into your table of contents, and then get set for conditional statements. So conditional statements, a conditional statement is one that can be written as an if-then sentence. We read them if P, then Q, or another way to read it is P implies Q. And in terms of symbols, we would have P, and then there's that kind of double arrow for Q. There are different symbols that mean essentially the same thing, but it says if P, then Q. An example, if a polygon has 12 sides, then it's called a dodecagon. The if part is called the hypothesis, or the premise, or sometimes it's called the antecedent. Hypothesis or premise are the words that we'll use more commonly in our class. The statement following the then is called the conclusion, or the consequent. Here are some examples. You might see a sign that says buy two, get one free. That's actually a conditional sentence. Even though it's not written strictly in the if-then form, the meaning is essentially the same. Or perhaps this one, all squares are quadrilaterals. That's a conditional statement. If something is a square, then it is also a quadrilateral. Or perhaps the famous statement, I think, therefore I am. Words of the famous René Descartes. That is a conditional statement, which says if I think, then I am, then I exist. There are a bunch of other related statements. So for example, if we have the conditional statement, all manatees are vegetarians, which we rewrite as, if something is a manatee, then it is a vegetarian. There's a similar statement called the converse. The converse switches around the hypothesis and the conclusion. So the converse of this statement would be, if something is a vegetarian, then it's a manatee. Now the converse and the conditional clearly do not mean the same thing. Investigate the converse. If something is a vegetarian, then it is a manatee. Well, I have a cousin who's a vegetarian. Does that mean he's a manatee? No. So the converse is not always going to be true if the conditional is. The inverse takes the negation of both the hypothesis and the conclusion. So the inverse of this statement would be if something is not a manatee, then it's not a vegetarian. And again, this is clearly ridiculous. Lastly, the statement called the contrapositive takes both the hypothesis and conclusion, switches them around, and also negates them. If something is not a vegetarian, then it's not a manatee. Now this statement actually is true. It's equivalent in logical value to the original conditional statement. And so let's cement this. We've got truth values of these conditional sentences. The conditional and the contrapositive are logically equivalent. And that means when the conditional is true, the contrapositive is also a true fact. Likewise, the converse and the inverse are logically equivalent to each other. Now, if you can write both the conditional and the converse as true statements, then it's valid to write a conjunction of these two statements. We call that conjunction a biconditional. And this is the one you've been waiting for. This is the if statement. So we write it in symbols with that double-sided arrow. If the conditional sentence is, if I'm breathing, then I'm alive. The converse is, if I'm alive, then I'm breathing. Now clearly both of these are true statements, so we can write the biconditional. The biconditional would say, I'm breathing if and only if I am alive. Or if you'd rather, I'm alive if and only if I'm breathing. The IFF is a kind of an abbreviation for if and only if. So remember, if the conditional and the converse are true, then it's valid to write the biconditional.